Initially I was showing microsolver, so this is the right time to talk. So it's good to add microsolver after adding velocity in the system. But as you can see, the current velocity looks quite boring. We can modify these before adding any microsolvers in here. So as you can see, we can visualize this velocity over here. So do we have any option to visualize that at SOP level as well? So let me just go over here and check velocity. So we cannot visualize this way. So there is a different approach for that one. So for that we will use volume trail. So first input needs point, second input needs that volume velocity. So here we can just use scatter. We can just scatter some points and connect this for here. As you can see, this looks very straight and I want to modify this. So for that we can use volume velocity and I can just connect this. So to add noise, we can just go to curl noise tab and let me add. Yep, so it's adding. So here I can just make some changes. So let's just use 0.25. So is this noise fine? Yep, it's fine. And in fact, we can increase this grain as well. 0.75. Yep. And let's increase scale as well. So as you can see, this is how it looks right now. Let me reset this simulation after adding volume velocity. Noise. Yep, there are some breakups. And there is too much force at the moment. It won't inherit that much. So we need to reduce that. So let's just reduce by 0.1. So let's just, and before making flipbook, let's visualize this in more better way. So to visualize this, let's use bake volume and we can connect this. So if I check this, I can just increase, let's just use 100 and change the color of it. Yep. And this is one way of visualizing, and there is another way also. You can use volume visualizer. So here also it's quite easy that we can just go here and mention the field, and after that we can use infrared. So if there is a high density, it will show different color. If there is a low density, it will show different color. Cool, let's just visualize this now, make a flipbook. Yep, this looks cool. We can enhance this by adding microsolvers. So let me just pin this over here and let me just quickly introduce. And current block size is 0.2. So is it working? So if I check 0.2, yep, it will work. That's fine. So for this scale, 0.2 is quite better. And yep, let's just make a flipbook. Let's reset the simulation and check the difference. Yep, we can see some difference. Make a flipbook. Yeah, this doesn't look right. So what's happening over here? So disturbance is working, but it's continuously adding noise till the end. So we don't want that. So as I have discussed then, it's a good idea to add microsolver after adding velocity. So if I just disable that and if I check inheritance value over here, so as you can see, there is force when it emits and after that it just slows down. Based on that we can add disturbance. And yes, I'm talking about the length only that we have discussed. That's why I was talking about in that depth. So how we can use that over here? Do we need to use wrangle to length? So the answer is no. Pyrosolver sparse is quite smart. So if I go to the simulation tab, I have that calculate speed field. So what it will do, it will just give same simulation, but it will add one more field, which is speed. And we can use this field to drive that disturbance. And how we can control the disturbance? If I go to shape and I have that option control, and here I can mention speed, and I have to give control range as well, so minimum and maximum over here. So here I don't want to put any random value, that so we won't have same speed object every time, right? So we need accurate value with proper visualization. We should be able to visualize that, right? So here there are multiple way to visualize that. So one way is this, that here we can just input that to speed, and I can just load over here, and this is the range. So this is value 1 and this is value 0. So I want to set cutoff till 5, right? So it will add that disturbance on red value only. So at the moment red value looks lesser, so maybe we can just reduce this value. Let's go till 0.8. So I need little bit only, so I can just break this shape over here. Let me just use that 0.5 and 0.8. Let's just reset this simulation. As you can see, there is a minor difference. That's what actually we want. And let's visualize this now. Cool, it's working quite good. And one more tip, you can use this multi-field as well for visualization. It's similar like volume visualizer if you don't want to use that way. And one more thing, so this simulation looks cool, but there is something wrong. So if we follow the real physics, there is always atmospheric drag. So there will be like impact, and simulation should slow down over time. So here also we need that similar behavior. So we need atmospheric drag. So let's just find out drag. So we have some drag force, but so those are for particles or RBD. But here, if you want to apply this over pyro, we can use dem. And where we need to connect this, we can connect this in the forces. Let me just use merge and I can just connect this. So let's just leave this default value and check. So always just check default value and you can just go extreme. Let's try both value. Yep, it's working. Let's just check extreme. How is it working? It's giving some weird result over here. Let's just check one value only. Yeah, so as you can see, extreme value is not working. So good range is 1. Yep, it's working. So I think we don't need that. Maybe 0.01. So this is always depend on which reference you are following, right? So always follow some reference. For now I'll just go with this value. I think that's fine. Cool. So now we have drag, And after that, let's add wind as well. So we need large noise for that. And if I select these, let me just increase size. Maybe I want this large wind. So let's just use turbulent for that one. So I can just go here, simply use gas turbulent, and I want that large swirl size. Cool. Let's just check what we are getting over here. Let's reset the simulation. Yep, it's working, but it's too much. I have to reduce this. Maybe 0.01, or let's go with 0.02. We did need that less value. So as you can see, wind is working. But what's happening over here? If I go to just this tab and visualize that, it's changing noise pattern, means it has some animation also. So if I go to this pulse length, so it has some noise, animated noise, right? So we need less animated noise. So to slow down, we can just increase this. Let's just check this now. So it won't be visualized this way, but we have reduced it. Can you see? It will stay in the one direction only. So if we don't use that, by this frame, it will change the direction. Let me reset the simulation. Yeah, it's changing its path a lot. So it should move slower, means the noise over it, and we can just overall reduce the scale as well. So this will be really minor effect, but it will work as a wind overall. So that's fine. Cool, let's just simulate this. Everything looks cool, but I don't want this in the simulation. So how we can break this edge over here? So first we can play around this with the speed and everything, but we don't have to depend on speed. We have other controls as well. So such as we can just check out density. So which frame was that? It's 79. Let's go to 79. Okay, so just check this. Let me reduce this. I want to cover more area. Yep. So this range is fine. So here we can introduce one more disturbance with same block size, and I want to use density over here, and we have defined the 0.4 and 0.7. So this will be the range. So let's leave everything default and just reset the simulation. Okay, so there is no effect. We need to increase this, double the amount. So after trying everything, we are not able to find the solution. So that's hidden over here, threshold range. So this is the minimum range. And if we check over here, so this is the minimum range it has over here. So we need to disable that range in order to add that. So here we can just keep everything default, and if I just show you this real quick, it will apply that. Right now you can see we are getting that noise over here. That's what we want. and we don't want that much. Let's just reduce to 60. And in fact, now let's just reduce the voxel size for better quality, and let's just quickly check that.